Hello everyone, so this is problem number 80 from the chapters Rotational Mechanics from the book H.C. Verma. Here it is saying that a thin spherical shell of radius r lying on a rough horizontal surface is hit sharply and horizontally by a cube. Where should it be hit so that the shell does no slip on the surface? Okay, so this is a spherical shell kept on the floor. Suppose it is hit at a height h from the center. So suppose has it is hit at this location. So impulse is given as I at this location. Now we know the moment of inertia of the cell is 2 by 3 m into r square if r is the radius of the cell. Now because of this impulse it will gain the sphere will gain some linear speed v and some angular speed. Okay, so the linear speed can be that is m into v is equal to impulse. So this v is equal to I by m. This is one thing. And second thing is angular impulse is I into h, and that is equal to 2 by 3. Oh, this impulse, this I and this I is different. Let me say this as I dash. 2 by 3 mr square into omega. So omega is and one thing we know that if it is uh, doing pure rolling, then omega should be equal to v by r, because in the pure rolling itself only uh, okay, here it is asking only about pure rolling, it should not slip. So if it is not slipping, then omega into r should be equal to v. Then substitute the value of omega in this, then we'll get I into h is equal to 2 by 3 mr square into v by r. R and r will cancel out. Substitute the value of v from earlier equation, that is I by m. So I will get cancelled out, m will get cancelled out. So h is equal to 2 by 3 r. So if we give an impulse at this height, so it will start pure rolling without any loss of energy or without slipping.